Hey guys, this is Einar. Welcome to your 21st tutorial in Basic Statistics 1 in Excel. Now, in this tutorial, we're going to talk about something called the standard deviation. And for more theory about what the standard deviation is, I encourage you to check the second theoretical tutorial in which we go through the concept of this formula in great detail. For now, we're actually going to calculate it in practice, so it should be viewed in combination with a theoretical tutorial for you to really get what this is all about. If we take a quick look at these two formulas, one is called the variance and one is called the standard deviation, and they are related in the sense that the standard deviation is the square root of the variance. So it's almost the same measure, but they're slightly different and they have slightly different meanings. The first thing we're going to need is that we're going to need our n, because we need to calculate our average of all of these x values. So we write equal to, and we need to count our observations. So we're counting the observations in our data set. We select it right there, our data set here. This is all the way to the end. We close the parentheses and we hit enter. We get an n of 25. In order to calculate the x bar, we need to sum up all of our x values. We select that data right there. We close the parentheses and we divide this by our n. Now, if you're unsure about the average, I encourage you to check the earlier tutorials on the subject because we have discussed it before. Okay, so I hit enter and we get an average of 21.32. So our average age in this material is 21.32 years. And that's great because now we're going to measure each observation's distance from the average, because that is what the variance and standard deviation is all about. It's about the variance around our average. So we need to actually calculate that variance in real terms. So I write equal to here. I take my x observation, 27 in this case, minus my x bar. Now, because I want this x bar to stay the same all the time, I put a dollar sign in there between them. I hit enter, and now I'm ready to just pull it down all the way down here. And I get these distances. In some cases, the x value is below average, and then in that case we get a negative number. And in some cases, it's above average. So 27, it's larger than 21, so it would be a positive number. 19, on the other hand, is smaller than 21.32, so it'll be a negative number. Now, this is a problem because the average, in fact, is the centermost guess, or it's a measure of central tendency in our data. So if we sum up all of these values, I select my distances right here, and I close my parentheses there, I'm going to get 0. And that's going to be a big problem because you can look at this formula here. I'm actually dividing this sum. And if that is 0, you'll just get 0 for everything. No matter what the values are here in x, we'll always get 0. And that means the formula is pointless. So we somehow have to turn these observations into positive numbers. And one way of doing that is by multiplying them by themselves. If you multiply a negative number by another negative number, you'll get a positive number. Now, we also need to do this for the positive numbers for it to be consistent. So we're going to go is equal to our distances, and then we raise them by 2, like that. And this sign, which means raise by in Excel, you find that it's right next to the enter button. You hold shift, you hit that button, and you press spacebar and you get it. Okay, so we do that, and we put all the way down for all of our values. There we go. We need the sum of all of these squared distances for the variance to be calculated, so we're going to sum it up down here. I'm going to sum all of my values. Like that. I hit enter and I get a sum. I'm going to put this sum here in my calculation square. Oh, it's in Swedish there. I should write calculation square. There. I'm going to put that sum in this cell over there so it becomes, just clear for us when we're calculating this. Okay, so basically we have all the parts of this equation that we need to calculate it. So I suggest that we just do it. When you write variance, you usually write s to the power 2. And that's interesting. Why don't you write just v or variance or something? Well, because the variance is the same thing as the square root of the standard deviation, people usually make a point out of defining the variance like this. That standard deviation raised by 2. So it's clear that we're talking about variance and it's related to the standard deviation. So we get right to it. We'll write equal to, and we need the sum of our square distances, which we have right here. And we're going to divide that by n minus 1. Why are we subtracting by 1? Well, it's something called degrees of freedom, and it's not something we're going to talk about in this course because it's a little bit too advanced for you guys. But it's a really interesting thing to discover. So I encourage you to Google it or check Wikipedia and just learn more about degrees of freedom. But it's going to be pretty advanced, so be careful. Now, what does this measure mean? Well, it's a measure of variance, but it's hard to conceptualize, you know, in real terms, like in terms of ages, because we're in a totally different scale. We're in a scale where we've actually raised all of our distances to the power of 2. So this really doesn't tell us anything. What we really want is we want to know the average distance from the mean, and that distance should be explained in terms of years, because that's what we're measuring in our x value. So we somehow need to get rid of this to the power of 2, and one way of doing that is drawing the square root out of it. If you draw the square root out of something that's up to the power 2, they actually cancel each other out. So what we're going to do is we're going to calculate this all over again, but this time we're going to use a function called square root. It's spelled like that, SQRT, and that tells Excel we want to find the square root of whatever we put into the brackets here. So we're going to put our variation into the brackets here, which is the sum of the square distances divided by n minus 1. So I close my brackets, and this is what the formula looks like. I hit enter, and I get a standard deviation of 7.56. Now, what does this number mean? Well, it means that on average, each one of these observations is on average 7.56 years away from our average age, which is 21.32. And this is a really important measure. We're going to use it a lot when we get into probability distributions. It's used a lot in statistics in general and in science. So it's something that you'll find great use for when you're calculating it. I'm really quickly going to show you how to calculate these things using commands. Okay, so what you do is you write equal to VAR, as in variance. And you have to go and select your data, your x values. So we select our x values, like so, all the way to the end. And we close the parentheses and we hit enter, and we get the same value that we just calculated. So this is a way of checking you've done everything right. We can also calculate the standard deviation. stdev. We go back to our data set and we select our x values, all of them. We go back and close the parentheses and we hit enter, and we get 7.56, which is the same as the stuff we've been calculating. So I wish you good luck with this stuff. I hope you have some fun doing it, and try to grasp the concepts, watch the theoretical tutorial. I wish you good luck and have a really nice day. Bye.